Okay, in this lesson we're going to be looking at how to solve applied problems. Okay, in this first part we're going to practice identifying which unknown quantity we should start with. Writing variable expressions when comparing two or more quantities. So one thing is being compared to another. It's best to use the variable for the quantity to which all the rest of the items are being compared. Usually it's the last quantity mentioned. Not always, but usually. We're going to choose a variable for this quantity. You can use X, you can use N, whatever you want. Usually I pick a letter that matches the problem. So if I'm talking about miles, I'll use M for miles. Then we're going to express all the other items using this same variable. Okay, so let's see. I'm just going to do this first part, the quantity. The height of a pole is 1/3 the height of the building. Define the variable expressions for the height of the pole and the height of the building. So here's my sentence. The height of a pole is 1/3 the height of a building. What is being compared to what? Pole is compared to building. Okay, the variable is going to be picked for the quantity to which everything else is being compared. So building is my X. In this case, I'm going to use B. B equals height of building. Now, when I do height of pole, it's not going to be P. It has to use B. And that's going to come from the sentence. The height of the pole is 1/3 the height of the building. 1/3 B. 1/3 B. Now I'm not solving anything. I'm just practicing this part. Writing my unknowns. Okay, let's look at the second one, or the next one. The second side of a triangle is 3 inches longer than the first. The third side is 12 inches shorter than 3 times the length of the first side. Now, let's do this in green. Okay, the second side is 3 inches shorter than first. So second is being compared to first side. And then it says the third side is 12 inches shorter than 3 times the length of the first side. So I'm comparing third to first. Since both of them are being compared to the first side is my variable. I'll just use X. I don't like to use S because my S's look like 5s. So X equals length of first side. So then my other unknowns, length of second side and length of third side, have to be written in terms of X. And I'm going to use my translation. To get second side is 3 inches longer than the first. Well, if it's 3 inches longer than X, that would be X plus 3. The third side is 12 inches shorter than 3 times the first side. 12 inches shorter, take away 12, 3 times the first side, 3x. And we're not solving anything. This is just all what we're practicing right now. Okay, next example. Okay, we're going to go one step further. We're going to translate our variable expressions into one expression and then simplify. Oops. A company's profit for the second quarter is 2 times the profit of the first quarter. The profit for the third quarter is 30,000 more than the first quarter. So our unknowns are profit for first quarter, profit for second quarter, oops, and profit for third quarter. Okay, which one is the plain variable? Well, the second is being compared to first, and third is being compared to first. So first is my variable, and I'm going to use P for profit. So my profit for the second quarter is 2 times the first. So that would be 2P. My third quarter is 30,000 more than the first quarter. That would be the first quarter plus 30,000. Okay, now we're going to use these these expressions in the next part. Write the following phrase using math. The profit for the second quarter minus the profit for the third quarter plus the profit for the first quarter. So I'm going to first write it's second minus third plus first. And then I'm going to put those boxes. Second is 2P minus. My third is P plus 30,000. So I have to be careful here. I don't want to subtract the P. I want to subtract the whole thing. So I have to use parentheses. Plus the first quarter is P. Second minus third plus first. Now I'm going to simplify, which means I'm going to have to distribute the negative. 2P minus 30,000 plus P. And I can combine my like terms. That will give me 2P minus P is 1P plus P is 2P minus 30,000. All right, now we're going to put these skills together to solve a word problem. Okay, if you are already comfortable doing these, you don't have to be so particular in writing everything down. But if you're not, please do it this way because it will really help you when you keep going. All right, next page. Jason is a foreman for a construction company. The apprentice for the company earns $7,400 less annually than Jason. The sum of Jason's annual salary and the apprentice's salary is $83,000. How much does each earn annually? Okay, this part of the problem is what we haven't practiced yet. Okay, this part we did. Our two unknowns are Jason's annual salary and apprentice's annual salary. One of them is just plain old X. Yeah, I'm going to use X because otherwise I would use S for salary and my S's look like 5s. So I'm not going to do it. Who is X? Well, in the second sentence it says the apprentice earns $7,400 less than Jason. So the apprentice is being compared to Jason, so Jason is my variable. Then if I'm going to translate that sentence, if he earns $7,400 less than Jason, the apprentice's salary would be X minus $7,400. Okay, now here's the cool thing. We used that sentence. We can cross it out. I don't need this sentence anymore. Don't let it confuse you with the rest of the problem. The next sentence is going to help me write my equation. The sum of Jason's salary and the apprentice's salary is $83,000. Well, what does sum mean? That means to add. So I'm going to take Jason's salary and add it to the apprentice's salary, and I will get $83,000. Now we're going to solve. This is actually where most of your work is going to be done, is step C. Okay, so I've got my equation, combine like terms, x plus x, remember there's like an invisible 1 there, 2x minus 7,400 equals 83,000. Add 7,400 to both sides, and we get 2x, because the 7,400s cancel, equals $90,400. Divide both sides by 2. X equals $45,200. Okay, now I've got my X, but what is X? Well, I've got that written down up here. Jason's annual salary is $45,200. Apprentice's salary is $45,200 minus $7,400. $37,800. Notice that I had two unknowns. I have two answers. Okay, now part D says check your answer. Well, to check that, I'm going to take the salaries, 45,200 and 37,800, and add them together. 83,000, which is what the problem said I should get. Okay, again, the check is there for you to make sure you have the right answer. All right, let's keep practicing this. It takes a little bit of time. Okay, Andrew walked 4 miles less than Dave last week in a boys and girls club walk for the homeless program. The two boys together walked 34 miles. How many miles did each boy walk? Okay, so what are our unknowns? Our unknowns are how far did Dave walk and how far did Andrew walk? Okay, one of them is just plain M. In the first sentence, it says Andrew walked 4 miles less than Dave. Andrew is being compared to Dave, so Dave is my variable. And I'm going to use M for miles. If Andrew walked 4 miles less than Dave, Andrew would have walked M minus 4. Okay, now I can ignore, let me do that in green. I can ignore this first part. I just used it. Now I'm going to focus on the next one. Together the boys walked 34 miles. Mathematically, what does that mean, together? Well, I'm going to add Dave plus Andrew equals 34. In part C, I'm going to solve. M plus M is 2M. Add 4 to both sides. Divide by 2. M equals 19. Well, who's M? M is Dave. Dave walked 19 miles. Andrew walked 19 minus 4, 15 miles. If I want to check my answer, I take Dave is 19, I take Andrew is 15. If I add them together, I should get 34. Okay, we're going to keep going. A triangle has a perimeter of 132 feet. The second side is 15 feet longer than the first side. Okay, this is a comparison. Second is being compared to first. The third side is 3 feet shorter than the first side. Third is being compared to first. We've got first side, second side, third side. Which one is my plain old X? Since they're both being compared to first side is my X. My second side is 15 longer than first, which would be X plus 15. The third side is 3 feet shorter, which would be X minus 3. Now I can cross that off. I don't need it anymore. Don't let it confuse you. What I haven't used is the first sentence. Triangle has a perimeter of 132. Well, here you have to know what perimeter means. The distance around a triangle. Well, that's adding the third side. The three sides, I mean. So it's first side plus second side plus third side equals 132. First, second, third. I'm going to combine my like terms. X plus x plus x is 3x. 15 and minus 3 is positive 12. So I combine my x's, and then I combined positive 15 and negative 3. Okay. To solve for x, subtract 12 on both sides, and divide by 3. X equals 40. Remember what x was? X is the first side. 40, and my label here is feet. My second side is x plus 15, 55 feet. And my third side is my 40 minus 3. Now I'm going to take my answers, 40 plus 50 plus 37, oops, that's why I didn't get the right answer, 55. 40 plus 55 plus 37, 12, 132. All right, in these next examples, I have taken out A, B, C, D steps because you'll just get the question. You won't have all of these written out for you. But I want you to follow the same method. So let's see this next one. Oops, page 6, sorry. Sarah is 2 years older than her friend Jessica. How old is each if the sum of their ages is 32? Okay, well, we have unknowns. My unknowns is Sarah's age and Jessica's age. One of those is just plain old A. Since Sarah is being compared to Jessica, Jessica is A. If Sarah is 2 years older, she would be A plus 2. Okay? Ignore this sentence. I don't need it anymore. How old is each if the sum of their ages is 32? Sum means add. Sarah plus Jessica is 32. So this would have been part A. This would be part B. Now part C is doing the math. 2A plus 2 equals 32. Subtract 2. 2A equals 30. And finally, divide by 2. A equals 15. Okay, again, what does A mean? Well, A is Jessica. Jessica is 15 years old. Sarah is 15 plus 2, 17 years old. If I wanted to check it, I would take 15 and add it to 17, and I get 32. Okay, number 5. The perimeter of a rectangle is 52 feet, and the length of the rectangle is 9 feet more than its width. Here is the comparison. Length is 9 feet more than width. My two unknowns are length and width. Which one is plain old X? Since length is being compared to width, in this problem, width is X. And since length is 9 more than width, that would be X plus 9. There's step A. Now I can ignore that part of the problem because I just used it. The perimeter is 52. Now again, perimeter of a rectangle. You have to know that's the distance around. And there's actually a formula for that. Perimeter equals 2 length plus 2W. Now, if you don't know the formula, you just have to know what perimeter means. There's a rectangle. Perimeter means add up all the sides. Well, you know that the length is X plus 9. You know that the width is X. So you just add them all up. If you know the formula, perimeter is 52. Length is X plus 9. And width is X. Distribute. If I didn't use the formula, I would have had X plus 9 plus X plus 9 equals 52. X plus 9, X plus 9. Combining like terms, 1, 2, 3, 4X. Well, that's what I have here. 2X and 2X is 4X. So it doesn't matter which way you do it, with the formula or with a picture. Subtract both sides by 18. (34 equals 4X. Divide by 4. I get X equals, that would be 8.5. And X is width. So X plus 9 would be 8.5 plus 9, which is 17.5 feet long. Okay, I'll leave the check up to you. Okay. All right. Other types of word problems that will fit this pattern. Consecutive integer problems. Well, what does consecutive integer mean? What does consecutive mean? Right next to each other, consecutive. The next one. So if one number is 12, the consecutive number is the next number, which is 13. Well, how do we get from 12 to 13 mathematically? We add 1. If our number is -8, what is consecutive? What's the next number? Well, that's negative 7. How do we get to it? Negative 8 plus 1 is negative 7. So if I don't know my number, I have x. Consecutive is the next one. Okay, don't say y. It would be x plus 1. Whenever you have consecutive integer problems, you will always use x equals first number, x plus 1 equals second number. Now, if there's more than two numbers, x plus 2 equals third number. I just keep adding 1 each time. So the only thing this does is that when you are dealing with consecutive integer problems, step 1 is already done for you, or step A. Okay, let's look at how this works. The sum of two consecutive integers is 27. What are the integers? So I'm going to start with my unknowns. First integer, second integer, because it said 2. Well, my first one is x, my second one is x plus 1. The sum is 27. So x, my first number, plus, because sum means to add, my second number, equals 27. Now I'm going to solve. X plus x is 2x. Subtract 1. Divide by 2. X equals 13. Now remember, x is the first number. My second number is 13 plus 1. Okay, let's look at another example. This one's going to be harder because the equation is harder. The sum of two consecutive integers is 17 less than 3 times the larger. Find the integers. Okay. I have two consecutive integers. So my first integer, my second integer. First number, second number. X, x plus 1. The sum of those two numbers, x plus 1, is 17 less than 3 times the larger. Well, 17 less means take away 17, 3 times the larger. Which one is larger, x or x plus 1? Yeah, x plus 1. 3 times x plus 1. I need parentheses because it's not just 3 times x. It's 3 times x plus 1. And now I'm going to do the math. On the left, I can combine like terms. On the right, I can distribute. On the left, I can't do anything, but I can on the right. So I'm going to rewrite the left side and do work on the right side. 3 minus 17 is negative 14. Okay, I haven't had one of these. X's are on both sides. It doesn't matter which one you move, but if you have been watching the previous videos, I always say move the smaller because you can avoid negative numbers that way. Move 2x by subtracting it. 1 equals x minus 14, and finally add 14. X equals 15, or 15 equals x. So my first number is 15. My second number is 15 plus 1, 16. Okay, other types of problems that fit this method, mixture problems. Okay, so we're going to use this same method for now. Two items are being mixed, not compared. So we can set either of them equal to x. To avoid negative variable terms, we're going to assign the more expensive item to x. It doesn't have to be done that way, but if you want to avoid negatives, that's what we're going to do. The other item will always be the total weight given minus x. The equation is always going to be the price or value of each unknown item times its weight equals total value. All right, so this is a little ambiguous, kind of hard to see, so we're going to do some word problems. A store manager mixes two types of nuts, in which one type sells at $5 per pound and the other type sells at $2 per pound. I'm going to make a 15-pound mixture that sells at $2.80 per pound. How much of each kind of nut is used? Okay, so we have two nuts, two kinds of nuts. And they don't give me any names, so we're going to say $5 per pound nut and $2 per pound nut. Okay, so on the previous slide I said to avoid negatives, I'm going to let x equal the more expensive. So x is the $5, and my total mixture, my $2 per pound, is going to be 15 minus x. Because if I mix them together and I get 15 pounds, if I have x of the $5 per pound, it's 15 minus x for the $2 per pound. All right, now my equation. My equation is going to be the number of pounds times its value. So it's 5x mixed added to 2 times 15 minus x will equal the total value, which is the total mixture, 15, times 280. Now I have my equation. Now it's all algebra. Distribute. On the left, I can combine my like terms. Subtract 30. It's kind of good to make a note of what kind of numbers you can't get for your answer. Well, if x represents how many pounds, I can get a fraction answer. I could have 2.5 pounds, but what I cannot have is a negative answer. So my answer is x equals 4. Remember that x was the $5 per pound. So 4 pounds, oh, let me write that because that looks like 41. 4 pounds at $5, and then 15 minus 4. 11 pounds at $2. Okay, the last one in this set of recordings. A store manager mixes two types of coffee, in which one type sells at $10 per pound and the other type sells at $16 per pound. Okay, so I'm just going to start there. I'm not even going to finish reading it. I am mixing a $10 per pound and a $16 per pound. How many pounds of each type? So I've got a $10 per pound coffee, and I have a $16 per pound coffee. Which one's X? To make it easier on yourself, make them more expensive, X. Now, the other one. What's the total pound? 16. So if my one coffee is X, my other one is 16 minus X. Then my equation is the amount, the number of pounds, times the cost. So 16 minus X times 10 plus 16 times 10 equals 16 times 1150. The weight times the value. I'm going to distribute 160 minus 10x plus 16x equals 184. Combining my like terms gives me 160 plus 6x equals 184. Subtract 160. 6x equals 24. Divide by 6. X equals 4. So again, I'm going to go over here. 4 pounds at $16. And then 16 minus 4, 12 pounds at $10. Okay, this is where we will stop this video. We'll continue this lesson on the next one.